Hey everyone, welcome to the Naughty Samurai channel. We are gonna delve into the concept of detecting and removing outliers using z-score in this video. In the very last video, we explored the concept of outliers using IQR, so if you want, you can check that out. Before we start today, make sure to take a moment, get comfy as we further dive into the topic. After this video, you will be able to properly detect and remove outliers using the concept of z-score. So let's get started. What is z-score? Z-score helps you identify how far a data point is from the mean. It considers standard deviation to find that distance out. Here on the left we can see there is a formula given which says z-score is equals to x minus mu divided by sigma, where x is the value itself, mu stands for mean and sigma stands for standard deviation. Here you can see the diagram which represents the distribution of data considering mean as the origin. It says about 68% of values fall within one standard deviation from the mean. About 95% of the values fall within 2 standard deviations, and about 99.73% values fall within 3 standard deviations from the mean. This rule is also known as the empirical rule, or we can simply call it the 68, 95, 99.7% rule. Now, how does this z-score helps detecting outliers? So what happens here is that if the value goes outside the range of 99.73% or 3 on either side, then that value will be considered as an outlier. So the rule of thumb here is that if z-score is greater than 3 or z-score is less than minus 3, the value will be an outlier. So if we put into example, then suppose we have x here, then will this value be considered as an outlier? Let me rephrase it. This u plus 3 sigma is the plus 3 that we are talking about over here, and this u minus 3 sigma is the minus 3 that we are talking about. So the rule of thumb says that if the value exceeds this 3 on the right side or this negative 3 on the left side, then that value will be considered as an outlier. Now we place this value here, and we can see that this value is within the range. It is actually within the 95.45% of data range. So will this value be an outlier? No, it is not an outlier. Now let me place this value here. Is this an outlier? This value is not an outlier either, because this is within this 99.73% of data range. Now let me place a value over here. Now is this an outlier? It is supposedly an outlier because this is lying outside the range which is given to us. It avoids the rule of thumb which says if z-score is greater than 3 or z-score is less than minus 3, the value will be an outlier. So this value for us is an outlier. Now let me show you the mathematical format for finding out the value of z-score using this formula. So let's go down a bit. Alright, let me draw a data set. We remove this and okay, so this, the name of this column is x. We have data 1, 2, 3, 4. Alright, that's enough. Let me rewrite it. This is not visible enough, so okay, this is 2. Now we know that the formula for finding out the value of z-score is x minus mu divided by sigma, where mu is the mean and sigma is the value of standard deviation, and x are all the values that are given here. We know that the value of mean and the value of standard deviation for a data set is constant. In this data set we have just one column, so the value will be constant over here. So let us suppose that mu is 2 and sigma is 8. Now we will find out the value of z-score one by one. First we will find out the value of z-score for this value over here. So for this we write z1, x is 1 minus mu means mean, which is 2. We will write 2, and down on the downside there will be 8, which is sigma. Alright, we will get the value over here. In the same manner we will find out the value of z-score for this. Okay, so z2, 2 minus 2, because mean is 2 and standard deviation is 8. In the same manner we will find it out for z3. 3 minus 2, which is the mean, divided by 8, which is the standard deviation, and the last one 4. So z4, 4 minus 2 divided by 8. Alright, so applying this formula, we fetch out the values of z-score for all the 4 values. During the practical implication part, you don't have to find out the value of z-score manually like this, nor you have to find out the value of mean and standard deviation. What you have to do is you just have to fetch out the values of mean and standard deviation of the overall data set, and then you will use that value of mean and standard deviation to find out the value of z-score. So now, as we are done with this part, now let's get into the practical part of it. I'm done importing all the necessary libraries such as pandas, OS, Seaborn, and matplotlib, and I'm using the same exact dataset that I have used in the previous video as well. So I'll be attaching the link to this in the description box below. After fetching the file out and printing the last 10 rows of the dataset, what we have to first do is that we have to fetch out the information regarding our dataset. For doing that, we will use the data.info command, and it will give us the total non-null count for each of the individual columns and also give us the data type for each of the columns. Now we will use the data.describe command to find out various values such as the values of count, mean, standard deviation, minimum value, maximum value, and the values of quartiles for each of the columns. As I said you in the theoretical part that we don't have to manually find out the values of mean and standard deviation before finding out the values of z-score. So as you can see here, the values of mean and standard deviation for all of the columns are given here. Now, the first thing that we have to do before we find out the value of z-score is that we first have to identify the presence of outliers. How can we do that? How can we know in which columns there is actually presence of outliers? I have explained you this part in detail in the previous video where we talk about detecting outliers and dropping them using the concept of IQR. So if you want to go into its depth, I actually suggest you to go check that video out, but I would kind of explain you this concept here in short. So here you can see, first to identify in which of the columns there is presence of outliers, you have to see the minimum value, maximum value, and the value of mean. So the minimum value here is 150. The maximum value is 81,000 in this applicant income column, and as you can see the mean value is just 5403. So let me write it over here. The minimum value is 150 and the maximum value is 81,000, and as we know that mean kind of lies somewhere around in the middle, so I'd write 5403. So if you think about it, is this 5403 actually in the middle? The actual mean should somewhere be around 40,000 or so, but it's just 5403. It's far away from the maximum value, which is 81,000, and kind of closer to the value of 150. So it's kind of being stretched towards the value of 150, that is the minimum value, and going further away from the maximum value. Why is it happening? It should be somewhere around 40,000, but there's presence of something that is kind of pushing it towards 150, that is the minimum value, and taking it further away from the maximum value. This happens because of the presence of outliers. We can also see the same thing happening in this co-applicant income column. Here you will see that the minimum value is 0, the maximum value is 41,667, and the minimum value is just 1621. As you can suppose, as you suppose that the minimum, the mean value should somewhere be around 20,000, but it's just 1621, which means it too is being stretched towards the minimum value and getting stretched away from the maximum value. So there is actually presence of outliers in this column and in this column as well. So we can choose any one of the column to deal with. I would choose co-applicant income, but you can try in both of the columns. Alright, there is another way that helps you detecting the presence of outliers, which is by plotting the box plot diagram. Plotting the box plot diagram is actually very easy. You will write sns.boxplot. SNS stands for Seaborn library, and within parentheses you will write the column name. As I chose co-applicant income column, I would be writing co-applicant income, and here in the parameter I would write data is equals to data. I am writing here data because we stored our data set in the variable data. If you chose dataset or D or anything, you just have to change it here. You will write dataset instead of data, but as I wrote data, I would be writing data here. Alright, now just run this. And alright, it's taking a bit amount of time. Alright, so now we have the box plot diagram. Here you can see that the values are dispersed. Most of the values are condensed here in the region less than 10,000, and there are values stretched further at 20,000, 30,000, 40,000. So this values, like this far-fetched values that are further away from the values which are dense over here, are the outliers here. So we have to deal with this outliers that is kind of stretching away the mean value for us. So this box plot diagram actually helps you identify the presence of outliers. Still, I hope you kind of understood this concept, but if you did not, I highly recommend you guys to go check the previous video out. Alright, so I am hoping that you guys understood the concept well enough to go ahead and find out the value of z-score. So let's get into our main concept, finding out the value of z-score. Now we know that z is equals to x minus mu by standard deviation. I'm writing it just for understanding. Alright, now what we do is we would write z-score is equals to data, our value of x are this values, the values that we're dealing with, or the x values here, are all these values, all these rows in this co-applicant income column. So we would write data, co-applicant income, and next co-applicant income minus data co-applicant income. We write dot mean over here. It will fetch out this mean value from this description. So we would write x minus u, that is data co-applicant income minus data co-applicant income dot mean, and next what we would do is we would divide it by data co-applicant income, and now we will fetch out the standard deviation value. Alright, that's enough. Now we will run it, and this should now print us the value of z-score. Let me run it. Alright, see, these are the values of z-score for all the rows. Now what we have to do is we have to place this z-score column into our data set. And how will we do that? For doing that, what we would do is we would write data z-score and equals to z-score. Alright, let me run it, and now I'll run the data set again, and now you would see that there you would find the z-score column at the very end. Here it goes. Like, now we have appended the z-score column to our data set. Alright, we already found out the value of z-score. Now the next thing that we have to do is we have to drop the values where the value of z-score is greater than 3 or less than minus 3. See, this was the rule of thumb, if you remember. If any value is, like, if the value of z-score is greater than 3 or less than minus 3 for any value, okay, yeah, if the value of z-score is greater than 3 or less than minus 3 for any of the values, then we will just drop that value. Now let's apply this concept. We would write data 3, and within it will be z-score, this will be less than 3, and again in the same manner it will be data, okay, data z-score greater than minus 3. Alright, I suppose this is it. This is the rule of thumb that we are talking about, and now we will just apply this rule of thumb into our data set, and what it would do is it would just drop all the values that are outside this range, that is if it is greater than 3 or it is less than minus 3. Alright, let me run it. Okay, we got our data set back, and now if you see here, it is actually just fetching out all those rows where the value of z-score is either greater than 3 or less than -3. Now the very last thing that is yet to be done is applying this concept into our very own data set. So we will copy this, we will write the name of our data set, which is data, we will paste it over here, and we will finally print it. And now you can see that all the values that are being shown here kind of obey our rule of thumb, which says that the value of z-score for all of these rows cannot be greater than the value of 3 or cannot be less than the value of -3. So this is it. If you want, you can cross check it again. Initially there were in total 630 number of rows, but after applying the concept of z-score, we can cross check it using the data.shape command, and you can see now the rows have been reduced to 608. So around 5 to 6 rows have been dropped, and those are the values that were actually outliers that we dealt with and dropped them successfully using the concept of z-score. So this is it for today, guys. I really hope that you liked the video and understood the concept well enough to actually hit the subscribe button, like the video, and share it with your friends if you actually found it helpful. So I will see you guys in the next video, where we will get into the concept of feature scaling techniques. So until then, keep your mind sharp, your code clean, and stay sane. The Naughty Samurai signing off.